histograms is that the distributions are all positively skewed. They look relatively similar to each other. Okay, so I'm going to assume that they are the same shape. So actually, the inference I'm going to make now is based off the median values. Okay, so actually, what this says to me here is that actually there's evidence to reject the null hypothesis. Okay, the significance is less than 0.05, so I'm going to throw away the null in favor of the alternative. So the alternative is telling me that at least one of these groups compared to one other group is different, okay? And their medians are different. But no, I don't have the median values here. I just have the median here of 62.67 for all exam grades. So maybe we should generate the medians and actually see what the medians actually look like. So I'm going to go to Analyze, Descriptive Statistics. I'm going to ask for frequencies, okay? I'll just reset this here. The variable I'm interested in is exam grade, so I'm going to put that in here, okay? Actually, I'm going to have to split the data set, okay, because I want exam grades split across the categories of age, yeah. So once again, I'm going to have to go to Data, Split File, and I'm going to say Compare Groups based off age, okay. So if that would have been over here, I just move across here. So I'm splitting exam grade now based on age. So I hit OK on that, and now I'll generate. Now I'll generate the median values. So I'm going to go to Analyze, Descriptives, Frequencies, okay. I'm going to put exam grade now in here. The statistics I'm looking for are, I'm just looking for the median value at this stage, so I'll just click median and I'll hit continue and I'll hit OK, and you'll actually see that we'll get the output here for our median values for our groups. It should be here somewhere. Oh, once again, I did this again. I didn't suppress the output, okay? So let me just, maybe I'll just get rid of this output here. Okay, let me just maybe delete that. Okay, can I delete this here? Okay. Can I delete it? No, I can't delete it. So let me just maybe run it again. Analyze descriptives, frequencies. I'm going to suppress the frequency table output because it's very long. It's like I've got 2,000 observations here, so it's going to be 2,000 rows in that table. So I'm just suppressing it, and now I'm going to hit OK, and we should get the output that we require. And here's our median values, okay? So you can actually see the median value, the median observation for the 20 to 30 year olds is about 53.4. It's around 53. For the 30 to 40 year olds, around 66, and the 40 to 50 year olds is around 62. Now, our test statistic, the Kruskal-Wallice test statistic, reported a significance of 0.000 or a p-value of 0.000. Just double click on this, and if I hover over it, my machine has gone pretty slow here. If I just look at this value here, if I hover over it, it should tell me what it is. Actually, well, it's not working there. My machine has gone a little bit slow, okay? But I mean, this value is less than 0.05, so we reject the null. So what's saying is that at least one of these pairings of medians is different. So it must be at least the difference between the smallest and the largest. So really what's saying is that the median observation for the 20 to 30 year olds is different to the 30 to 40 year olds. But it could also be between the 20 to 30 year olds and the 40 to 50 year olds. There could be more differences, yeah? So we'd have to follow this up with a post hoc test. But from a median perspective, because the distributions, the three age group distributions have the same shape, I can make inferences with respect to the median values, okay? If they hadn't got the same shapes, okay? For example, if the one was negatively skewed, that's definitely, we have a situation where they're not all the same shapes. Well, then we'd have to infer something in relation to the mean ranks, okay? In which case we're still rejecting the null, but the null position being that the mean ranks of the groups are the same, okay? So we reject it. So at least one of these pairings is different. And once again, the logic is it must be the difference between the smaller and the larger one at least, yeah? It could be other possible pairings. But still we're saying that the mean ranks are different. But actually when we were reporting this result, we'd report this result based off medians, yeah? Because we know that the shapes of the distributions are the same. That's really it. That's the Kruskal-Wallice test. Very similar to the ANOVA, okay, from a logic perspective, okay, but has two variants. It has one where we can make inferences based on median values, and one where we can make inferences based on mean group, but mean rank values, okay. We can only make the inferences based on medians when the distributions have the same shape, okay, relative to each other, okay. If they don't have the same shape, well then the only inference you can make when you do reject is with respect to mean ranks being different, okay. So guys, once again, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And I hope that this video, another video in our series of videos dealing with non-parametric tests through SPSS, and in particular the Kruskal-Wallice test, I hope that this was in some way intuitive, and more importantly, I actually hope that was helpful for you. And thanks for watching.